What's going on, man? I know it's been a while, so let me get right into it. The other night, man, I was on a panel with some flat earthers, and they seemed to duck, dodge, not answer. They couldn't answer what I was saying. So I'm going to pose the question to you and see if you can answer it if you're a flat earther. All right? Because I don't think it's possible for you to answer it. Now, with making some sense anyway, I'm in Washington, D.C. in the D.C. area. Now, on December 21st, it's our shortest day of the year. We have approximately 9.5 hours of daylight, direct sunlight, sun above the horizon. You can see the sun. I ain't talking about no three sun foolishness that I've heard some flat earthers try to bring up to justify or to use cognitive bias to justify their belief system. 9.5 hours. Now, let's go to this AE map. I know some flat earthers have discarded the AE map. However, some still use it as a reference. And you don't even have a model. And one of the reasons why you don't have a model is because it doesn't comport with observable reality. That's just a fact. So let's see here. In DC, I made these small suns because they represent the shortest day of the year. Here's the international date line, or what they call that. And that is the prime meridian, or the 0 degree line of longitude. It's 24 lines here. I have the number on each line. 24 lines of longitude. They represent 1 hour apiece. Sunset will be there for us here in DC, where I'm pointing to now. We have a little less than 10 hours of daylight during December 21st. All right. So let's go to Argentina, which is one of the southernmost cities in South America. All right. During December 21st is their longest day of the year. I want you to think over what I'm saying. As we used to say in grade school, put on your thinking caps. All right. 17 hours, approximately 20 minutes of direct sun above the horizon in the one of the southernmost cities in South America. Sun rises at 4:51 and it sets at 10:11. I want you to think over this, flat earthers. If you have, just think now, the minds that you have, or you say you have, why you can't come up with a model? Just think about what I'm saying now. All right, now also, just to mention, we have 3 levels of twilight: civil, nautical, and astronomical twilight. During this day, after sunset, 17 hours, 20 minutes later, for the rest of the night, they in Ushuaia are in nautical twilight, which is in between civil and astronomical. So they see light all 24 hours, but yet the sun is above the horizon for 17 hours, 20 minutes. Now let's go back to the map. Here in Ushuaia, sunrise will be about here. Now I'm in DC, I'm closer to the sun right here, yet they are seeing it before me. Now I have these suns and these numbers directly over the Tropic of Capricorn, which during December 21st, the sun is directly over the Tropic of Capricorn. Okay, so going all around from between 21 and 20, all around 22, 23, 0, 1, 2, 3, all the way around to between 13 and 14, they are seeing the sun directly. But yet I'm here in DC and I don't see the sun here, but yet they can see the sun? Come on, partner. You know that don't make no sense. It doesn't jive with what we see. You already know that. So why are you coming out your rectum with some foolishness, coming up with the three suns, the Pac-Man sun. Everybody have their own individual sun. Come on, son. It doesn't make sense. But let's go to a pretty accurate app called Celestia. Now, right now, I have the motion at 100 times faster than actual speed. And I have it locked on the Western Hemisphere so that we can see South America and North America. So we're moving with the rotation of the Earth. Now we got to go on 1,000 times faster because I want to get it at December 21st so that you can see how it would look on the globe. And you can try to fit it to all the maps that you can come up with. It just doesn't work. This is why Tiger Dan trying to make a map. He realized, man, it just doesn't work, man. Put some work in. Put some research in. Put some observations in. And you will bear witness that what you've been observing cannot possibly work on a flat earth. And the only thing that it can possibly work on is a spherical shaped earth. I know some flat earthers say that you can't see or look into the sky and tell what's under your feet. Well, when you have multiple facts, you can do that. And this is one of the reasons why. All right. But anyway, that's another subject for another time. But I want to see if some flat earthers can answer this question. Now, we're on December 21st, right? And right now is at about 6 hours of UTC time, which is Universal Coordinated Time. Now, direct sunlight, Ushuaia is about to come in direct sunlight right about now. Okay, so around 8:30 UTC, Ushuaia will be coming in direct sunlight. It's not precise to the second, but it's giving you an approximate. All right, so around 8:30 Universal Coordinated Time. Now let's look at the DC area. It's not in direct sunlight yet. But as we go further, right about now, so around 12:30 UTC, which is about 4 hours difference from Ushuaia, DC is coming into sunlight. Give or take a few minutes, right? Okay, let's speed it up a little bit. And let's get around to nighttime. You see the Terminator line is tilted because the Earth is tilted 23.5 degrees to the plane of its orbit, right? This creates our seasons. And it creates our daytimes as well. So now we're getting to about 20, or okay, we had 21 UTC. DC is leaving direct sunlight right about now. So around 21:30, DC has left direct sunlight, right? Now we're moving 500 times faster than normal, but let's try to get a pretty accurate time when Ushuaia will be leaving direct sunlight right about now. So you have over 3.5 hours of direct sunlight at the end. Man, it just doesn't work for a flat earth, but you see it's working on the globe earth. It ain't hard to tell. I'll holler at you soon. Later.